I'm astronomer Doug Duncan of the Fisk Planetarium at the University of Colorado Boulder. Welcome to Explorations, the series that takes a look into NASA's diverse projects and the people who make them happen. We're accustomed to big, expensive rockets carrying big, expensive satellites. The Hubble Space Telescope is the size of a bus. It weighs about 12 tons and it's 43 feet long. Spacecraft of this scale take decades of research, development, building, and testing to ensure successful missions. NASA is broadening space exploration through a new kind of satellite, the CubeSat. CubeSats are tiny satellites built in units. A one-unit CubeSat is only 10 centimeters on a side, about the size of a Rubik's Cube. The Miniature X-ray Solar Spectrometer, or MINX, is a 3-unit CubeSat from the University of Colorado Boulder. Built mainly by graduate students, it studies solar flares and their impact on Earth's upper atmosphere. Solar flares are eruptions on the sun that shoot out particles and high-energy radiation such as ultraviolet light and X-rays. This X-ray light reaches the Earth in only 8 minutes, where it's absorbed by our atmosphere. This protects us and heats the upper atmosphere. The flare's particles travel at slower speeds, taking anywhere from hours to days to reach Earth. They pose a serious hazard to the health of astronauts and satellites, so we use the X-rays as an early warning system. These particles are part of what's called the solar wind. Solar flares can increase the strength of the solar wind, and this can cause problems for satellites, such as our GPS satellites, and for communication. CubeSats are relatively inexpensive and fast to build. Whenever possible, they use low-tech parts. MINX's small solar panels open with fishing line, and it uses a measuring tape like you'd find at a hardware store as part of its radio antenna. Let's meet Chris Moore, who as a graduate student helped develop the MINX CubeSat.
Growing up in the Chicagoland area, I did not see many stars at night. But on a trip out into Alabama as a youth in the wilderness, I looked up at the night sky and there were stars everywhere. You could say I was starstruck. This inspired me to major in physics and astronomy as an undergraduate, and eventually as a graduate student to work on the Miniature X-ray Solar Spectrometer CubeSat, which we like to call MINX. MINX measures X-rays from the sun, and personally, as part of the MINX team, I helped test the detectors, wrote a lot of the software to analyze the data that's returned from MINX, and also study the outer atmosphere of the sun, which is very hot and we're not sure why, but the data from MINX will help us understand why it is so hot. So following my dreams allowed me to work on MINX. If you follow your dreams and do not let anyone deter you from those dreams, you can achieve your goals in the future.
CubeSats don't just study the Earth. The first one to go to the moon will launch soon. The Lunar Flashlight is a 6-unit CubeSat built by NASA's Jet Propulsion Lab and Goddard Space Flight Center. Led by scientist Barbara Cohen, its mission is to search for water on the moon. There are craters on the moon's south pole whose bottoms never see the sun. Lunar Flashlight will shine a laser into these craters and measure the reflected light to see if ices are there. Since ice is more reflective than soil or rock, a laser can detect its presence, thus the name flashlight. Water on the moon could be used to sustain human life and to create rocket fuel, which could make future space exploration cheaper. Lunar Flashlight will tell us how much water there is and where to find it. You might say that the CubeSat business is really taking off. To date, more than 800 have been launched. Their ease of design and low cost have allowed more researchers to develop more missions and more people to work with satellites. CubeSats and NASA's Small Business Innovative Research Program have inspired many commercial companies to offer small satellites of their own. Soon, companies will be able to buy little satellites for all kinds of missions. A new revolution in space is coming. Big science in small packages, promoting research, discovery, and business in space. If you enjoy building things and exploring, maybe space is in your future. On behalf of NASA and Fisk Planetarium at the University of Colorado Boulder, thank you for joining us for this episode of Explorations.